Hello, I am Dr. Ellerby and I teach organic chemistry at UNE. In this video, we're going to examine how to approach a problem that is a predict the reactant or reagent type of problem. A similar problem is 3.42 in your text. In a general form, we're going to be solving this kind of problem. A reactant, which we don't know, a reagent, which we don't know, and making a known product. We're going to use this problem as an example. We have a reactant acting in the presence of a reagent, producing cyclopentanol. The general approach we use is to look at the product and work backward. Backward, not forward. The first step is to determine what has been added to the hydrocarbon. In this problem, it's easy to see that the hydroxyl group has been added. So here's the hydrocarbon part, and here's the hydroxyl group. And so it's the hydroxyl group that has been added. Our second step is to figure out what reagents could add a hydroxyl group to an unsaturated hydrocarbon. Doing that requires that you know what reagents produce what products. Yes, you could look it up in your text, but by the time you redo these problems in review for the exam, you should not have to look them up in your text. You need to know them. Anyway, so we go through our mental list and we decide that adding water in the presence of acid to an unsaturated hydrocarbon would produce a product with a hydroxyl group in it. So we've got a reactant, reagent, cyclopentanol. The reagent that will make a OH present in a cyclopentene molecule is H2O plus H. So we now have reactant plus reagent H2O in the presence of H plus going to cyclopentanol. We've now figured out what reagent to use. Our third step is to find out, was anything else added in addition to what we decided in the first step? Well, when we add water, we're adding a hydroxyl, and we are also adding a hydrogen because water has an OH in it and an H plus. Please note that my program will not allow me to make subscripts, so you'll just have to put those in your minds. The step 4 is to determine the location of a double bond. And by the way, the same logic applies to a triple bond. So here is cyclopentanol. We rewrite the product to show an H. This H was always there, of course, but we now show it, we write it out to make the process easier to see. The hydroxyl and the hydrogen must have been added on adjacent carbons because we know they add to a double bond, which can only be formed between two adjacent carbons. It doesn't matter which carbon the H is shown on, as long as it is adjacent to the carbon with the hydroxyl. So the H could be here, or it could be there, and it doesn't matter which. So the carbons to which the hydroxyl and the hydrogen were added must be the carbons of the double bond. And here it is. So, to summarize, step 1 is to determine what has been added to the hydrocarbon. Step 2, what reagents could add a hydroxyl group to an unsaturated hydrocarbon. Step 3 is to find out whether there was anything else added that we determined in the first step. When we add water, we're adding a hydroxyl and a hydrogen. Step 4 is to determine the location of the double bond. That's it. Thanks for listening.